Hello and welcome everyone. Distributed Database Management System. My name is Kurdo Jaza Mahmoud and I'm explaining this chapter of Database Management System class. Now, we would have our course outline. We would start with evolution of distributed DBMS, advantage and disadvantages of DDBMS, distributed processing and distributed database, characteristics of distributed database management system, distributed database management system component, level of data and process distribution, distributed database transparency, distribution transparency, distributed database design. Now, our objectives. By the end of this lecture, you should be able to first explain what a centralized DBMS is and why it has problems. Second, understand how and why distributed database management system was created. To know the advantages and disadvantages. Now, the fourth one, understand the component and how they work, then explaining transparency type distribution, transaction failure, performance, and lastly, understand fragmentation, replication, and data allocation. Now, introduction. Back in the day, database was on a big single system sitting in one place. Now, just as imagine one giant warehouse storing all of the company's data, all application program had to go there and one place to get data. Now we have this application 2, application 3. We have database management system and we have the actual database. Now, the DBMS, database management system, would be the software for managing, manipulating, controlling, descriptionizing the database. Now, why distributed database management system was needed? The old single location database had limitations, so a new concept was born, and we call it as distributed database management system. The key idea is the database split into pieces and stored different locations, not in one location. Now it is stored in different location. Even though the data is spread out, the system treats it as one logical database. Now this is spread out. Yeah, data is spread out, but still they will all go to one place, for example, in here, and everything would be in here. And one of the important topics is the user doesn't feel the difference. It still feels like one database. Now, just imagine you have a supermarket and each supermarket has its own stock, but that supermarket chain, for example, any of the supermarket in Suleimania, they have their own stock, but there would be also a warehouse that all of them, they could go there and take any item that they want from the warehouse. Now, a centralized database lives at one node or one site in a network of computers. All other sites, 1, 2, 3, 4, 5, or any number that comes to your mind, connect to that one location through communication network. Now, only one site actually holds the data for centralized database. Imagine 5 offices connected to one headquarter. Only HQ has the files, everyone else calls HQ to get the information. Now, it has some problems. It will has some problem 100%. So problem with centralized database are like this. And here's why this approach failed over time. The first one was performance get worse. A more remote site connect, the system slows down. Now, also expensive to maintain. One giant database costs a lot of to manage. Reliability issue, we cannot rely on it. If that one site goes down, everyone loses access. Or single point of failure. Now bottleneck, too many requests equal to what? Traffic jam at the central site. Also poor availability. Data is not efficiently accessible to remote users. Now to understand all of these points, just imagine having one ATM machine for entire Soleimania. Now we will have all of these problems even more. Now the distributed database. DDB, distributed database concept. The solution was to spread the data across multiple sites or cities, each with its own computer and storage. The key point here is all distributed data still consider one single logical database. Location transparency. User just ask for data and get it without needing to know where it's stored in reality. The system handle finding the data automatically. Now, what is distributed database management system? So, in order to know this, we have two important definitions. First, distributed database itself, a collection of multiple logical related databases spread across a computer network. Distributed database management system, on the other hand, it would be the software that manages this DB and makes distribution invisible to users. Now, the keyword here, transparent, that you need to be aware of it, which is equal to what the user doesn't see or feel complexity behind the scene. They just use it normally. Now, the factors that help distributed database management system to grow, we have four major trends help this distributed database management system become widely accepted. The first one would be internet as a business platform. Now, companies moved online needing distributed data. Also, mobile and wireless revolution, smartphone and tablets needed data from anywhere. Apps and services, cloud-based apps like Google Docs store data across servers. Now, the last one would be mobile business intelligence. Nowadays, managers need real-time data on the go. Basically, the modern digital world demanded the distributed database to exist. Now, imagine a company based in New York with a database made of six tables, A, B, C, D, E, F. Now, here is New York. Here is New York, as we can see in here. And there's are the tables A, B, C, D, E, F. All of them are in one place. Now we have the centralized way, which is all six table in New York, but the companies has offices in different states of America. Los Angeles, Memphis, New York, Paris, and Tokyo. The simplest idea is to move each table to where it's used the most. If, for example, table B is used in Tokyo, please take the B and put it in Tokyo, and so on for the others. Now, the distributed data, so that the table distributed like this. Now, in the Tokyo, we have D and E. In the Paris, we have F. Now, in Memphis, we have three. We have table C, and in New York, we have A and B. Now the table F is in Paris. Paris employee can access it without calling New York every time or saving telecommunication costs. And local autonomy means Paris employees can take responsibility for their own data, including security, backup recovery, and controlling simultaneous access. It's like each branch managing its own files instead of always asking HQ or headquarters for everything. Now, distributing data brings a new challenges. And the very first one would be join becomes complicated. Just imagine in here, everything is in New York. You can join the tables in the way that you want. Now, it is not the same case in here. Two in New York, one in Memphis, two in Tokyo, and one in Paris around the globe. Now, joining those tables will not be that easy. In centralized system, no problem, but in distributed system, two tables might be at different sites, of course. Now, that system has to fetch data from multiple locations across the network to complete the join. Advantages and disadvantages. Now we know that the distributed management system, as everything else in the computing world, has its own advantages and disadvantages. Now the advantages would be data are located near the greatest demand site, faster data access and processing, growth facilitation, improved communication, reduce operating costs, user-friendly interface, less danger of a single point failure, processor independence. Now you see we also have disadvantages. complexity of the management and control, technological difficulty, security, lack of standards because we have different sites, increased storage and infrastructure requirement, and of course, ultimately, it will also need a lot of cost. Increased training cost incurred due to the requirement of a duplicated infrastructure. Now, these two concepts are often confused. Here is the difference. Distributed processing, the database stays at one location, but the processing work is shared among multiple computers. For example, one computer handles input and validation, another generates reports. However, in distributed database, the database itself is split into fragments stored at a different location. Each fragment can also be copied, also we mean replicated at other sites, all fragmented together from one logical database. Now we have site A or site 1, site 2, site 3. Now we have site 2 and 3. They can all access the site 1 computer or the DBMS through a network. And database record are processing in different location, as we said. Now, distributed processing environment, the three important rules to remember. Distributed processing does not require distributed database. You can share processing tasks while keeping data in one place. Now, just like this, for example, this computer generate a report. This computer, or let's say this workstation, will do some updates, but every data would be saved in here. If they do something, they would access it from here. Both require network, distributed database, and distributed processing. They both need the network to connect the components together. Now, in order for me to call a system distributed database management system, it must have these functions: application interface, validation, transformation, query optimization, mapping, and I/O interface to read and write data, permanent storage, mapping to know where each piece of data is located, query optimization to find the fastest and the best way to get the data, transformation to break complex requests into smaller, simpler ones, validation is to check if data requests are written correctly, application interface to communicate with users, apps, and other DBMS. Now, is it only this? No, we also have formatting to present data properly to user application, security to protect data privacy for both local and remote database, backup recovery, database administration, concurrency control, and transaction management. Now, a distributed management system must do these three things. First, do anything a regular centralized database management system would does. Handle extra challenges that come with a distributed data processing. Do all of this transparently so the user would know if there's two database or 10 database. Now we have these components that we will talk about each one. Computer workstation, sites or nodes, network hardware and software, communication media, transaction processor TP, also known as call or called application processor or transaction manager. Now this is the software on each computer that requests this data. It receives and processes both local and remote requests from an application. Now, the data processor or a DB would be also we can call data manager. This is software on each computer that stores and retrieve data. Now, it can even be a full centralized DBMS on its own. Now, the key rule shown in the diagram, in this diagram, we have TP, TP, DP, DP. Each TP can access the data on any DP. Each one of these, for example, can access the data on any DP that you can see in here. For example, this one can access this DP or this DP or even this DP. Each DP handle all requests for the local data from any TP. And this DP, for example, this DP says, I'm glad to serve you. Anyone that comes, DB will serve it. Now, the function of a distributed database management system is first receive the request from application, then the validate and analyze the request to check for errors, map the record to find where data is located, decompose the request into smaller input-output operation, search and validate the actual data, ensure consistency, security, integrity of the data, validate data against specific condition, and then lastly, it will present the data required format for the user. Now, the level of data and process distribution. Database system can be classified based on two things. First, where the data is stored. Second, where the processing happens, single site or multiple sites. Now, this gives us a table of combination. Single site process, single site data, we call it host DBMS. Now, single site process, multiple site data, it is not applicable. How about multiple site process, single site data, file server, client server DBMS, and so on? And the multiple site process, multiple site data would be fully distributed client server, distributed database management system. So we have these single process, single data, and multiple process, single data, and multiple process, multiple data, because this one, the single site process, multiple site data is not applicable. So we have these three. Now, SPSD, single site process, single site data, this is the most basic and oldest type. And what do I mean by this? It is centralized model. Everything processing happens on one computer, host computer, all data stored in the same computer local disk. End user have no processing power. Users access system through dumb terminal, screen with keyboard, but no computing ability. Now, this is the architecture of the centralized database or distributed management system. Or sorry, this is the diagram for explaining the centralized database or the oldest way of saving data. We have these T's or these workstation that they will all go to the same place, and through the DDBMS will look at the database and get anything that, for example, this workstation asks, and it will just give it. Now we have multiple process single data. Multiple processes run on a different computer sharing single data repository. Now we have multiple processes and we have single data repository. Now require network file server running on a conventional application, for example, connected through LAN as we see communication network here. Also, the client server architecture reduce network traffic, processing distributed and support data in a multiple site. Now, the MPMD, multiple site processing, multiple site data, is a full distributed database management system. It fully distributed database management system support multiple data processor and transaction processor at multiple site. Classification of a distributed management system depending on the level of support for various type of databases. Now, the types are homogeneous, heterogeneous, fully heterogeneous, meaning all the sites are used the same type of distributed management system. Heterogeneous, different type of DBMS are used in a different site. Fully heterogeneous, different DBMS and different data models on each site or in each location. Now, multiple site processing, multiple site data, full DBMS. We have site one, the CPU distributed management system. Also, this site has its own CPU and distributed management system, and the database fragmentation A, database fragmentation 2, each one has its own fragmentation, and the single logical database. Everything still held in single logical database. Now, even distributed management system has some limitation. First, remote access is read-only in some system, meaning you can view data from another site but not always change it. There are limits on how many remote tables you can access in a single transaction. And there is a limit on how many different databases you can access it at once. Lastly, there are limits on what type of database model can be accessed remotely. Now, a good distributed management system must provide 5 types of transparency to the user. Distribution transparency, transaction transparency, failure transparency, performance transparency, and heterogeneity transparency. Now, you may ask me, where is distribution transparency? User does not know where the data is located. and they don't care, to be honest. Now, transparency. Transactions are handled safely across multiple sites. Failure transparency. System keep working even if a node fails. Performance transparency system perform as if it were a centralized database. Heterogeneity transparency. Different type of database work together seamlessly or smoothly, or as we say, with no problem. Now, level 1 fragmentation transparency is the highest, which is the levels of distribution transparency. The fragmentation transparency is the highest. Users do not know the database is fragmented. They write normal queries and the system automatically finds that combine the needed fragments. Level 2 location transparency is the medium one. Now, in this one, users know the fragment name but do not know the storage location. Now, the lowest user must specify both fragment name and node location where it's stored. This requires the most user involvement. Now, a distributed data dictionary is also a topic that we need to cover in order to understand the entire process. A distributed catalog that stores metadata about the entire database. It replicates across all network nodes and helps manage transparency and data access. Now we have this table, fragment name. For example, the SQL statement require the fragment name, yes. Location name, yes. Then the DBMS support local mapping and level of distributed transparency is low. Now, for this one also yes, but the location name no, location transparency, and it is medium. Now the fragmentation transparency will doesn't need location name, no. Doesn't need the fragmentation, no. And the level of distribution transparency is the highest one. Now we have a distributed database management system, employee table, E1, E2, and E3. These are the fragments, and the location of each one will be New York, Atlanta, and Miami. Now the employee table is divided among three locations, no replication. Suppose an employee want to find an employee with the birthday prior to January 1st, 1970. Fragmentation transparency would be this. Select all from employee where employee date of birth is, let's say, smaller than the 1st of January 1970. Now you can see just a normal SQL syntax without anything. Now the location transparency. Now select from E1 where employee date of birth is this. Union select all from E2 where employee date of birth is this, and union select all from E3 where the employee date of birth is 1st of Jan 1970. Now how about the local mapping transparency? Select all from E1 nodes NY where EMP date of birth is 1st of Jan 1970. It specified the name and the place. E1 employee table 1 and it is in New York. Now we would do a union, so we had like a plus. Select all from E2 node at Atlanta where the EMP date of birth is 01 or the 1st of Jan 1970. Same for E3 nodes Miami where employee date of birth is 1st of Jan 1970. Now, distributed database design. Designing a distributed database involves three key decisions. First, data fragmentation. How do we split the database into pieces? Now, this is the first decision that we need to make. Now, how about the data replication? Which pieces should be copied at multiple sites? Also, another decision. And lastly, data allocation. Where exactly do we store these pieces of copies? Now, data fragmentation. Let's talk about the first one. A single database object is broken into two or more fragments. Each fragment can be stored in any site across the network. Information about each fragment is stored kept in a distributed data catalog. Distributed data catalog. Now, the transaction processor TP use the DDC or distributed data catalog to find data when processing users' requests. Now, horizontal fragmentation, vertical fragmentation, or a mixed fragmentation. Now, the horizontal fragmentation with the division of a relation into subset or fragment of a tuple, tuples, or rows same schema. Now, vertical fragmentation, division of a relation into attribute column subset. Each fragment must contain the primary key. How about the last one, or the mix of both horizontal and vertical, would be combination of horizontal and vertical strategy. Now, this is horizontal fragmentation. Now, this is the vertical fragmentation, and this is the mixed one. Because you see, we have horizontal, we have vertical. Now, horizontal fragmentation example. Example, horizontal fragmentation of a project relation. Project 1, project with a budget less than $2,000, let's say, and project with a budget greater than or equal to $2,000. Now we have project J1 and project J2. Now, define using selection operation of a relational algebra. Now we have a budget is smaller than 2,000 for the project. Now we have the budget, selection budget for smaller or equal to $2,000 project. Now the vertical fragmentation example. Example, project 1 information about the project budget and project 2 information about the project name and location. Now this is the budget and this is the project name and location. Now define using projection operation of a relational algebra. This is the projection, and we will say the projection of P and O and budget for the project, or the project number and the budget, and the project number and project name and location, as we have it in here: project number, project name, and location. Now, a sample customer table. We have customer number, name, address, state, the limit and balance, and customer rating, customer due. Now, horizontal fragmentation of the customer table by state. Now we have a customer H1 have all of its address, and H2 address and state and limit and everything. Now the customer H2 location is in Georgia. The node is ALT, node is TAM, and node is NAS for this one, Tennessee. And for Florida, the table name is customer HS, H3, H2, H1. Now, vertically fragmented table content. Now we have a customer V1, customer V2, or vertical 1, vertical 2. Now the location service BLG, node SVC, and node ARC. Now we have the vertical fragmentation of the table. Two separate areas in the company use different fields in table: the daily activity, the service department, and the collection department. Now, mixed fragmentation of the customer table. Now, this table divided horizontally by the three states. Within the each state, there's a vertical fragmentation by department. Now, the table content after the mixed fragmentation process, we have such a thing. Now, motivating example, we have a customer, which is one to many, and we have an order that have order ID, date, and amount, and customer number that has a relation with the order line, one to many, product number, order number, and order city, and it is many to one with the product and one to many with the inventory. Now, fragment based on the customer region column. Here's the codes. Create the fragment Western customer AS. Select all from customer where the cost region is West. Or create the fragment Western order AS. Okay. Select all from the order and customer where order customer is equal to customer, customer number, and the customer region is equal to West, and so on. Now, the correctness rules. Completeness. Any data item must be covered by the least one fragment. If you have a big table and all of the data inside it at least need to be covered by one fragment. Reconstruction. There exists there exists relation operators select, project, or join to reconstruct the original table from fragments. Horizontal fragmentation union, vertical fragmentation join, and hyperfragmentation combination of relational operators. Now, disjointness, remove duplicate data. Horizontal fragmentation, a row cannot appear more than one fragment. Vertical, non-key attribute cannot appear in more than one fragment. Now, data replication, storage of a data copies at a multiple sites served by a computer network. Fragment copies can be stored in several sites to serve specific information requirement, not just like that, not just that we like it. It will serve a specific information requirement, can enhance data availability and response time, can help to reduce communication and total query costs, imposes the additional processing overhead, of course, which copy do we read when submitting a query. All copies must update it when a write occur. Now, data replication, we have site 1 DB A1, DB A1 and A2. The site 3 data process has A2. Now, replication scenario, fully replicated database store multiple copy of each database fragment at a multiple site. Can be impractical due to amount of overhead. Now, partially replicated database store multiple copy of same database fragment at a multiple site. Most distributed the database management systems are able to handle the partial replicated database well. Now, unreplicated database store each database fragment as single site, no duplicate database fragmentation. Database size, usage frequency, and cost performance overhead management influence the decision to replicate. Data allocation, deciding where to locate the data distribution over a computer network is achieved through data partition, data replication, or a combination of data partition and replication. Now, allocation strategy, centralize the data allocation, entire database store in one place or the traditional one. Partitioned data allocation, database is divided into several disjointed parts or fragments and stored over several sites. Replicated data allocation, copies of one or more database fragment are stored over at the several sites. Now, these are the reference that has been used for creating these slides. And if you have any question, feel free to reach out from me and send me an email. Thank you very much.